All right, workout 3. We're trying to find the uh, moment of inertia or the rotational inertia of each system. So we're just going to go ahead and redraw these out so that we can annotate them. So we've got mass here, we've got a mass here, got a mass here, we have a mass here, and we are going to rotate them about this axis. Um, So we have our um, moment of inertia for each individual mass that we can calculate from our equation sheet that is demonstrated there. So for each of these, we know we've got a distance L that we are away. So this distance here is L. Um, this distance here is L. And these are all mass M. So in order to find I, we're going to have to find the I of each individual mass and add them up. So we'll label these guys as 1, 2, 3, and 4. So for mass 1, I equals mr squared from our equation sheet here. So in this case, our m is going to be just m. Our r, or our distance away from a rotational axis, for mass 1 is 0. So that goes to 0. For 2, it's the exact same thing. We have a mass m, and we are 0 away, so that whole thing goes to 0. For mass 3, we have mass m. This time we are distance L away. And for mass 4, we have the exact same thing. Mass m, distance L away from our rotational axes. So when we add those up, we have I total is going to be equal to 0 plus 0 plus ml squared plus ml squared. So that final one is going to be 2ml squared. Now, we can annotate that's the final answer, and we'll take a look at B. So in this case, once again, we have these same 4 masses, and we are rotating it about the center. So we're going to rotate it about this point instead. These are still a distance L apart, but that means that if we cut that in half here, so in half, that means that we have L over 2 away from our rotational axes. So those are L apart, L over 2 away from the rotational axis. Once again, this will be 1, 2, 3, and 4, and they are all mass M. So if we find I for any of them, I is again going to be mr squared. So for block 1, or mass 1, that's a mass of m, and then we have a distance away from our rotational axis of L over 2 squared. For 2, it's the exact same thing, ml over 2 squared. 3, same thing, ml over 2 squared. And 4, ml over 2 squared. So our I total is equal to, since they're all the same, I'm just going to write it as 4 times ml over 2 squared. And if we reduce that down, what we wind up with is ml squared.